Hey, how's it going? This is Joe Rule. I'm going to show you how to create particle effects like the ones in this VSE Corrosion Control video. First of all is the particle system itself, which is driving the motion of the particles, how they move, gravity, resistance, rotation, that type of thing. Second of all is the goal function, which attracts them to vertices on a model, which in this case is a factory, a globe, excavator, semi-truck. And thirdly is the instancer function, which replaces the particles which are not renderable in the particle system with small polygon objects like you see here. Alright, let's jump in and see how to create this. Okay, first of all, we're going to create our goal objects, which will form the outlines for our shapes. Now, the tricky thing with getting this to work properly is that the vertices, the number of vertices on each of the models, and the number of particles all have to be pretty close to the same number. Now, the easiest way to figure that out, I'll show you how I did it for the VSE Corrosion Control video. If we go up to Display menu up here, and the heads-up display, it's going to give us two options. One is the poly count, and the other is particle count. Click on poly count. It's going to give us different counters here for the number of vertices on our objects and in our scene. And as well, we're going to go to the HUD and select particle count. And when we get our particle system going here, this is going to give us a live count of the number of particles active. Alright, so for our goal objects, we're going to go up to Create, Polygon, and go to Sphere. And I'm going to give this a radius of 10. And give it divisions of 25 and 25. And these are numbers that I've already pre-figured out in order to make the number of vertices and the number of particles in the system match. And then we're going to go up to Create, Polygon, and Cube. And this is going to be 20 units square with 10 divisions on each side. Okay, so we have our two shapes, and I'm going to go to the channel box and put these at the origin. Okay. Now you'll see here up in our heads-up display, the object that I have selected, which is the cube, has 600 vertices on it. And if I select the sphere, that has 602 vertices as well. And I'm going to name these Poly Goal 1 and Poly Goal 2. Now the next thing we'll do is create our particle instance object. This is going to serve as our particle farther down the road. I'm just going to create a platonic solid. And we're going to set the radius to 1, like so. And if we zoom in here, I'm just going to select this and press F. You'll see it's looking a bit mushy. So what I'm going to do is go to the Polygons menu set, go to Normals, and harden the edge. That gives us a much more geometric look. Okay, so I'm going to select both of our goal objects here, actually all three of those, and press Ctrl-H to hide everything. And now we get into the particle system. We're going to go to the nDynamics menu set, go up to nParticles, create nParticles, and we'll stick with points and then click Create Emitter. And then right away here, I'm going to extend out the timeline. If I click play, you're going to see we have particles in our scene. The first thing I'm going to do is change the gravity of the system, and that is in our nucleus settings. I'm going to go to the attribute editor, click on nucleus, and switch the gravity to 0. That way, when it generates particles, it just balls up in one place. So the next step is going to be to make sure that we produce the proper number of particles to match with each of the vertices on our goal objects. Right now, if we go to our emitter settings, you'll see that we are emitting at a rate of 100 particles per second. So I know we're shooting for about 600 particles, so I'll set that to 600. And then go forward. We're at 24 frames per second, so I'm going to go to 25 frames to be sure that we run the full 24 frames. Set a key there. Go forward 1 frame, which is Alt period on the keyboard. And then I'm going to set that to 0. Right click and set another key. And now if I go back to the beginning and click play again, bam, it goes right up to 600, exactly 600 particles, and then stops. Okay, so we have the proper number of particles being emitted. We have the proper number of vertices on each of our goals. Now the next step is to start shaping those particles into the goal shapes. So I'm going to select my nParticles system and then hold Control or Command if you're on a Mac, and then select Polygoal 1. And I'm going to go up to our menu and go to nParticles and then select Goal. And if we click on our nParticle system and go to the attribute editor, scroll down to our goal weights and objects, you'll see that we have a goal here for polygoal shape 1, and it's set to 0.5 weight. If I go back to the beginning of the timeline and click play, now our particles are going to form the sphere shape. Now you will see that they're moving really wonky right now. So what I'm going to do is change the damp value. And that is in the dynamic properties of nParticle shape. I'm going to set the damp to 0.1. Basically what the damp value is it makes the particles look like they're traveling through water. It slows them down, and they also stick to the vertices of the goal object better, because they don't have as much energy in them. Now this value here, the polygoal shape, determines how much each of the vertices on the goal shape is attracting that particle. So if I set this all the way up to 1, you'll see that the particles immediately jump without any interpolation in between. They immediately jump to each of the vertices of the goal shape. If I set it down to 0.1, it's going to be really slow. So we'll leave it at 0.5 for now. Now, what we need to do next is add our second goal. So I'm going to select the nParticle system again, hold down Command, select our second polygoal, go to nParticles, and then click on Goal. And then when we play back again, it's going to be all crazy because we have 2 goals now, and they're dividing the influence between both of them. Both of them are set to 0.5. And if I play it back, I can actually play around with this live to determine the shapes. I'm just going to set this to 0 and this to 0.5 for now. Now, let's say we have these two polygonal shapes, and for some reason one of them is not the shape that you want. You want to replace it with another one. But, there's no option here to delete it. You can't select it. You can uncheck and make it inactive. You can't get rid of it without deleting the shape itself. So what I'm going to do is select our nParticle system. I'm going to go up to Window and go to the Node Editor. This is it's kind of like a behind the scenes look into Maya and how each of these objects relates to the other one. And be sure that our particle shape is selected, and then I'm going to hit this Input and Output Connections button here to graph the connections on this node editor. Alright, so here we have connections between each of these nodes showing their relationship. If I pop this open, you can see all the different options for the particle system. What we want to be worried about is these goal shape 1 and 2. And all we have to do to break the connection between the goal shape and the particle system is just to click and drag on one of these, and it breaks the connection. And if we select the particle shape again and go back to the goal weights, you'll see that it's gone now. I'm just going to undo that. You'll see it's back again. I'm just going to rename our solid real quick here, call it polyparticle. Now, our next step is going to be to keyframe our goal values in order to get the particles to morph into the different shapes. So, at 30 frames, I want the particles to be in the shape of the sphere, and then at 60 frames, I want it to turn into the shape of a cube. So I'm going to set a keyframe at 0 at 29 frames, step forward 1 frame, Alt period again, or Alt right arrow. Set it to 0.5, set another key. And then at 60 frames, what we're going to do is turn off the first goal shape and turn on the second goal shape. So I'm going to bounce back 1 frame, 59 frames, set a key, and then set a key here as well. Forward 1 frame, set this to 0, set a key, and this to 0.5, and set a key. So now at 30 frames, our sphere goal turns on, and then at 60 frames, our sphere goal turns off, and our cube goal turns on. Go back to the beginning. It's like so. Okay. Now, right now, all we have are these ugly white particles. They don't even show up in the render. We need to attach some actual geometry to each of these particles so they can show up. And we'll do that through instancing. What we're going to do is select the polyparticle, go up to nParticles, and then instance or replacement. I'm going to click on this box here to bring up the options. And you'll see it automatically names it. It knows which object that we want to instance. It knows which particle system we want to use. Position is set correctly, but rotation needs to be set to rotation per particle. And what that will do is give us random movement. Each particle is going to rotate independently of all the rest of the particles. We get that nice random positioning of the particles, and that way they don't all move with their z-axes straight up and down and looks really artificial. In order to get that option, we need to go back to the nParticle system and go into the rotation settings. We're going to check compute rotation, and we're also going to turn on the self collide. And that way the particles will actually collide with all the rest of the particles in the system. So I'm going to select our polyparticle again, go up to our nParticle menu, instance or replacement, and then you can see our rotation is set to rotation per particle. All the rest of the settings are okay. I'm just going to click create. You'll see it created an instanced object here. And if we go back to the beginning of the timeline and click play, we now have geometry on our particles. You can see they're completely freaking out right now because all the particles are colliding with each other and jerking around. So what we're going to do in order to get that random positioning, as soon as the sphere object goal turns on, we want to turn down the collide width scale. So right now it's set to 1. I'm going to go to 29 frames, set a keyframe, forward 1 frame, and set it to 0. And that'll give us nice random positioning of each of the particles without them glitching like this. What I ended up doing in the original video, the original corrosion prevention video, was between each of the transitions that happened, forming from one shape to another, that self-collide width scale I would turn up and then turn off, so that it got some nice random movement while the particles are transitioning to a new shape. They bounce off of each other. Then when they lock into a new shape, they stop and don't move anymore. So make sure that key is set. When I play this back, you have some random movement here, random rotation on the particles. In order to fix that, what I'm going to do is change this rotation damp value to 0.1. And that'll stop that rotation. There we go. You get some nice random positioning, like so. You can see here I have 600 particles and 602 vertices on each of the shapes, so I have a small hole here. That could be just positioned away from the camera. You'd never see it. So we have instance geometry in our particle system now. We have a rotation set up, dealt with any excess movement. Now it is worth noting, I'm going to unhide this polyparticle just by pressing Shift H and then pressing F to focus on it. This relationship between this particle and with all the other particles in the system is live. So if I hit R on the keyboard for scale and scale this, it affects all of them. And if I right click and go to vertex mode, I can actually, I'm hitting W for the move tool. I can edit this live, edit the geometry live. I'll just undo that. Okay. And I'll hide that again. Now the last step of this process is going to be to bake out the simulation so that it can be rendered. Because if I go back to the beginning and I try to scrub through this, it generates a few particles, doesn't calculate properly. Yeah, all sorts of bad things happening. So what the baking process does is it goes through the animation frame by frame, calculates each one, and then saves it to your hard drive. All right, I'm going to select my nParticle system, go up to Ncache, create new cache, and you'll see it automatically detects which folder it wants to put it in because I have a project already set up. Cache name is okay. All the rest of the defaults are okay. Just click create. And it's going to play through the animation and calculate every frame and save it to the hard drive. And when that's done, you'll see I can scrub through this now, and it's all saved. One last tip. When creating a shader for this polyparticle, I would keep the shader fairly simple. I just used a Lambert in the VSE video and added some glows and other things in After Effects after it was rendered. I initially tried to create a semi-transparent, reflective material, and with this number of particles, the number of particles that I had in the scene with VSE, the render times were absolutely astronomical. So keep it simple. Just do a Lambert, change the color. Doesn't need to be anything fancy. And make the particles look fancy in your post-processing program, in your compositing program. Let me know if you have any questions or suggestions for future tutorials. You can follow me on Facebook at Joe Rule Artist, on Twitter at Joseph Rule for more technical tutorials and blog posts every single week about tapping into your creative subconscious, living an alternative creative lifestyle, and what happens when art and business collide. See you next time.